All right, let's dive straight into this explainer. Today, we're unpacking an absolute financial and engineering mystery from Pakistan's energy sector. We are going to look at the entire life cycle of this massive industrial megaproject, from its super high stakes beginning right down to its, well, pretty unprecedented conclusion.
Okay, take a look at this. One single solitary dollar. Now, what's wild here is that this is the exact price the Pakistani government recently paid to acquire a fully functional, completely world-class power plant. Literally, just $1.
So the big question we really need to figure out today is how? How does a massive infrastructure asset, one that originally cost something like $560 million to build, how does that legally and mechanically depreciate down to a final handover price of a single dollar bill? I mean, how does a facility valued in the billions of rupees change hands for the price of a candy bar?
To make sense of all this, we gotta rewind to part one, the birth of an energy giant.
So picture this. It's the early 1990s, and Pakistan was just desperate to solve these crippling rolling blackouts that were absolutely paralyzing its industrial growth. To get around public financing limits, the government rolled out the 1994 Private Sector Power Generation Policy. But to attract foreign capital, well, they had to set up this incredibly complex funding structure. We're talking a 67 to 33 debt-to-equity ratio, backed by international heavy hitters like the World Bank, the Japan Export-Import Bank, and some major German investment corporations.
And looking at this timeline, you can see the plant moved fast. It was built under a build, own, operate, and transfer framework, which basically means a private company builds it, runs it for a while, and then eventually hands it right back to the state. So they broke ground in 1996 and kicked off commercial operations in late 1999. But here's the real kicker. Look at 2004. It was originally designed to run on heavy furnace oil, but when global prices spiked, they had to do a massive, crazy fast, 3-month technical shutdown to convert the whole thermal complex over to natural gas.
All right, with the history laid out, let's move on to part two, inside the power complex.
Now, this wasn't just your run-of-the-mill facility. The sheer scale here was staggering. You're looking at a 450-megawatt thermal giant, powered by these elite, German-engineered Siemens gas turbines. It used a super reliable combined cycle configuration and essentially intercepted the massive 500-kilovolt transmission corridor. It was basically pumping power straight into Pakistan's backbone infrastructure to keep the whole region stabilized. But here's the thing. Running world-class German machinery in the middle of a rural agricultural area, that requires some serious top-tier talent. So to keep those engineers around, the company basically built this insulated, closed-loop lifestyle. The staff lived in this exclusive bubble. We're talking air-conditioned executive housing, pay scales matching international oil and gas benchmarks, indoor gyms, tennis courts, and even dedicated medical centers. It was a massive corporate luxury perk that, really contrasted with the agricultural reality just outside the gates.
But right about here is where our story shifts. Global economics started turning this utopian energy giant into a massive fiscal burden. Let's check out part 3, the capacity payment trap.
To really get why things went south, we have to talk about a specific contractual term, take-or-pay. See, when the plant was built, the state signed a 30-year agreement that actually guaranteed they'd pay for the plant's availability regardless of whether they actually needed any electricity from it at all. It's kind of like, imagine hiring a taxi to just sit in your driveway 24/7. Even if you never step foot inside it, you still have to pay the driver for their time. Crazy, right?
Well, that taxi suddenly got way too expensive to keep around. After the Russia-Ukraine war started, global spot prices for liquefied natural gas completely skyrocketed. And at the exact same time, all these cheaper hydel and coal plants from the China-Pakistan economic corridor were coming online. So Rousch got pushed way down on what the state calls its economic merit order. Basically, it became just too expensive to actually turn on, but because of that contract, the state was legally locked into paying billions just to keep the thing on standby.
Which brings us to this pretty staggering number, 0. Shockingly, in the 2023 to 2024 fiscal year, the plant's actual power dispatch to the national grid dropped to practically 0. It just sat there, completely idle. And this forced a huge national reckoning over these legacy contracts that were just absolutely draining the treasury. So, facing this totally unsustainable circular debt, the government formed a special task force to aggressively renegotiate early retirements for these legacy plants. That brings us to part 4, the historic asset handover. Now, instead of getting dragged into some bitter, drawn-out international legal battle, Rousch and the government actually managed a peaceful early exit. In October 2024, they signed a negotiated settlement agreement. Rousch voluntarily gave up its sovereign guarantees, meaning they walked away from years of future capacity payments. And in return, the state cleared out their outstanding legacy debt. So by December 31, 2024, the private corporate operations were permanently shut down.
And that brings us perfectly back to where we started. Since that original contract said the plant had to be handed over eventually anyway, this early settlement finalized the historic transfer of an asset valued at roughly 35.6 billion rupees for a nominal single US dollar. The plant officially changed hands, just like that.
But here's the catch. Taking ownership of a massive power complex is one thing. Actually knowing how to run the thing is a whole different ballgame. The state brought in an entity called NPMCL to take over, but they totally lacked the technical capability to operate those massive Siemens turbines. So to stop this elite machinery from just immediately deteriorating, the government had to scramble. They actually bypassed standard procurement laws, giving out emergency exemptions just so they could hire third-party contractors to keep the lights on, literally, and keep the facility functional.
So, where exactly does that leave this massive monolithic structure today? Let's take a look at Part 5, Legacy and Future Status.
Today, the corporate ecosystem of Altern Energy and Rousch Power is totally dissolved, gone, and it leaves behind this really complex dual legacy. On one hand, we have to recognize the past. For 20 years, this plant successfully stabilized regional manufacturing. It literally kept textile mills running during some of the worst power crises. But the present? The present reality is stark. It's just sitting there in preservation and standstill mode. It's basically a massive state liability, costing millions in the budget just to keep the sensors lubricated so the metal doesn't degrade.
Right now, the state is weighing a few different pathways to figure out what on earth to do next with this incredibly valuable but totally stranded physical asset. Do they pass it to the Privatization Commission to try and find a new buyer? Do they just liquidate the assets outright? Or do they try to repurpose it into some sort of alternative state-operated energy configuration? It's a massive puzzle.
And really, this whole handover leaves us with a pretty profound dilemma to think about. How do developing nations balance the desperate need for emergency infrastructure today without trapping future generations in completely unsustainable financial agreements tomorrow? When you consider the massive undertaking required just to keep a nation's lights on, the long-term financial shadows those decisions cast are huge. Anyway, I hope this explainer helped you grasp the fascinating, high-stakes reality operating behind the scenes of the power grid. Thanks for hanging out with me, keep learning, and keep asking those great questions.